Assalamu alaikum. We are going to start with the first lesson, energy. At the end of this lesson, students will be able to revise the work done by a constant force and the power, define an energetically isolated system, define the total energy of a system, define the internal microscopic energy of a system, determine the mechanical energy of a system, distinguish between conservative and non-conservative forces, finally apply the principles of conservation and non-conservation of mechanical energy of a system. In this video, we're going to remember only the work done by a force and power. Let's define work. The physical meaning of work is different from its everyday meaning. Consider a lady pulling a bag with a force F1. The bag then is displaced. On the other hand, a man pulls a wall by a force F2. Applying this force day and night will not make any movement. So we say that F1 does work, while F2 doesn't do work, although F1 less than F2. By comparison, we say that a force exerted on a system does work when it influences the movement of that system. So the fact is, no work is done without force and or without displacement. Work performed by a constant force in a rectilinear motion. What is first a constant force? A constant force is a force with constant line of action, direction, and magnitude. It means it doesn't vary with time. Now, the work done by a constant force along a displacement AB at its point of application is the scalar product F vector by AB, and it is denoted by F vector scalar product AB vector, which is F times AB times cosine F AB. The unit of work is joule, the unit of force is Newton, the unit of AB is meter, while the angle is either degree or radians. And cosine changes its sign according to alpha. Since AB is positive as a magnitude, F is positive as a magnitude, cosine, when it's negative, the work will be negative. Cosine is 0, then work is 0, and if cosine is positive, the work is positive. How come we have different signs? If the angle is an acute angle, if the angle is acute, the work is positive, and we say that it is motive. When it's obtuse, the work is negative, and we say that the work is resistive. And it depends on the direction of F with respect to AB. If the motion from A to B is to the right and the force is trying to pull it against this motion, then it will be obtuse. And the opposite, if AB is to the right and F is pulling it with the direction, like the first case, so it is acute. The final case, if alpha is 90, it means the force is just perpendicular to the displacement, then the work is 0, and we say that it is null. The work done by constant force along a curvilinear displacement. In the case where the trajectory is curvilinear, the work is independent of the path followed, but it depends on the initial and the final positions. So we say the work is the same, F times AB times cosine alpha, where this alpha is taken between the force and the line joining AB. Let's study the work done by a particular force along a curvilinear path, like the weight. Consider a body descending downward along a curvilinear path from A to B under the effect of its weight. The rule gives us work done by mg equals to mg vector dot AB vector. But AB is curvilinear, and since work is independent of the path followed, so let's choose AB as AD plus DB. Expand this product, we can find that it is mg dot AD plus mg dot DB, which means that mg AD cosine 0 plus mg DB cosine 90. But cosine 90 is 0. In addition to that, dB is perpendicular to the mg vector, so it's just mg AD. Naming the heights of B and A respectively as HB and HA, we can write this rule as mg into HA minus HB. So we always have the work done by mg, which is a constant force, equals to mg into H initial minus H final. Note that the work done by weight has different types according to H initial and H final. If the motion is ascending as the first case, H initial is less than H final and the work is negative, so we say the type is resistive. If the motion is descending, H initial is greater than H final and the work is positive, so we say the work done by weight is motive. If it's just horizontal motion, so H initial is equal to final and the work is zero, so we say it's a null work. Finally, any motion that starts and ends at the same position has a zero work and we say it is a null work. Let's solve this application. A car moves in a straight horizontal path under the action of a constant motive force F of 10 exponent 4 Newton and subjected to constant frictional force F of magnitude 10 exponent 3 Newton. Determine the work done by each external force exerted on the car in the displacement AB equals 10 meters. So what are the forces acting on this car? We have the normal reaction, which is vertically upward, weight, which is vertically downward, friction, horizontal, opposite to the tendency of motion, and F with the direction of the motion from A to B. So the work done by the normal reaction and the work done by mg is zero since mg and n are perpendicular to the displacement AB. While the work done by the force F, the force of the motor, is F dot AB following the rule F AB cosine 0. The answer is 100,000 joules. The work done by friction is F vector dot AB vector. And here the angle between F and AB is 180 since F and AB are opposite vectors. So the answer is negative and it is minus 100,000 joules. Mechanical power. The power is an algebraic quantity that measures the rate of work. It is defined as an amount of work per unit of time. For a quantity of work, delta W, provided during an interval of time, delta T, we define the average power by P average equals to delta work over delta T. Power is expressed in watt, delta work is expressed in joules, delta T is expressed in seconds. The instantaneous power. The instantaneous power corresponds to the limit of the average power when delta T tends to 0. So we say the instantaneous power is the limit of delta work over delta T, the limit of P average as delta T tends to 0. And the answer is just the derivative of work with respect to T. dW equals to F dot dr in this case, since we are dealing with constant force, and the last answer is P instantaneous equals to F vector dot dr vector by dt, which means that it is F dot v vector because dr by dt is simply the velocity vector. Finally, we say the instantaneous power can be written as F times v instantaneous times the cosine of the angle between F vector and V vector. F is expressed in Newton, dr is expressed in meter, V is expressed in meters per second. To sum up the ideas we took in this video, first we say that the work done by a constant force is simply F AB cosine alpha. The work done by weight is mg H initial minus H final. If the angle is acute, we have motive force. If it's obtuse, so it's a resistive work. If it's 90 degrees plus or minus 90, the work is null. The average power is delta W by delta T. And finally, the instantaneous power is F
times v times cosine the angle between f vector and v vector. This is the end of the first part. Thank you for watching.